Hi, everyone, and welcome to Data Scientists' webinar series. We're very excited to have everyone here today with once again a great guest that I'll introduce in just a few seconds. Before we start things off, as always, a quick little reminder what Data Scientist is, what we do, and what you can expect from us. Besides running this great webinar series, Data Scientist, we are also one of Europe's leading training providers on everything data science, data analytics, data engineering, DevOps engineering, related with a great hybrid format. So if you're ever excited about maybe stepping into a new career or advancing into new technologies, feel free to check out our website, and there you'll find some of the great courses that are available European-wide, and also some great funding option in case that's always a topic. But without further ado, I would love to introduce today's guest, speaking on a topic that he'll master a lot better than I will. We have today Peter McIsaac, who is a product owner for data analytics and a senior data science consultant, sorry, at MID GmbH, based out of Nuremberg, Germany. Peter, welcome.
Thank you.
And thank you for accepting our invite. And well, I think without any further ado, I can just kick things off. I think I'll step away for the time being. Quick reminder for everyone, please feel free to ask your questions, whether you're on LinkedIn or YouTube, in the chat. Even drop a little hello and maybe tell us where you're currently listening from, because that's always a nice thing to see. Don't hesitate to put the questions in the chat. I think we'll leave, and we have a bit of time for Q&A at the end of the session. So in case we don't pop up directly with your question, that's perfectly normal. It's because we'll leave a little bit of time afterwards. But in any other case, thank you so much, Peter, for attending and for accepting our invite. And I think I'll let you do the interesting talk from now onwards. Thank you so much.
All right. Thanks so much for having me. Just as a pointer as well, we had some issues getting the PowerPoint to present properly. I can't go into full presentation mode, so hopefully you'll be able to see everything well enough. I'm going to talk today about automated candidate ranking using LLMs, and sort of the way I've organized my comments. I'd like to just briefly introduce my project team to you, say a bit more about the goal that we're looking to achieve and some of the background to that, go over our data sources and how we're handling our data, talk through our approaches, some of the results that we've gotten, take a brief look at the way that we're presenting the outputs that we have, how we're interacting with our stakeholders, and sort of where things go from there. And I have planned for plenty of time for questions at the end, and I really welcome questions and feedback and that sort of thing. Our team, we are a small team on this project. It's an internal one at MID, but it's still something that is actually being viewed with a great deal of importance. As was introduced, I'm the product owner of data and analytics and the senior data scientist and consultant at MID. I'm working quite closely with Simona Hopp, who is also a data scientist and consultant. And at the project outset, Florian Horn was the PO of data analytics and senior consultant. He's no longer with us. And Simona and I took over the project when he left. But just to give credit where it's due, I didn't do all this on my own. And to come to what is at the heart of this project, and I'll say a bit more about the process that we're looking to address here, but there's a problem faced by our account management people, and it involves matching candidates to project requirements as they come in. And this process is very, very manual at this point. It's costly, both in terms of man hours and it's the amount of effort it takes, and it's extremely slow. And these are two things that are less than ideal. And the cost in terms of time and money is readily apparent, but they're also concerned that it can take too long for them to get effective responses back. And the goal is to automate these processes to lower costs and to get faster response time. And that's at least what things were at the outset. There's been an additional thing that has come into play as we've worked on the process. And there's also potential in this automation process to increase consistency, but I'll say more about that later. I decided to present on this project when I was invited, really for two reasons. One is the process that we're addressing here is of interest actually to a lot of departments at the MID. Human resources, our sales department, our team leads have very similar things that they're constantly having to carry out, and they're all very interested in this. And I suspect that there are actually quite a number of companies that have related processes. And so I was hoping that the problem that we're addressing is somewhat widespread. And then the other thing that I really want to also sort of get into is the challenges that we have really gone beyond what you often find when you look, say, using LLMs to do natural language processing tasks. We have actually, for our perspective, small data sets. We have to work in German, so doing natural language processing in German is more challenging. There's not as much trained in German as in English. NLP has a lot of unlabeled data. We have that as well. That's not so unusual. We only have a few data sets that we can use to test what's going on. And a lot of the vocabulary we're dealing with is domain specific. And so all of these things are things that we're grappling with. And one of the things that I wanted to do in presenting this is to get into terrain that I wasn't really that familiar with before I got into this project. And I'm happy to talk about these challenges and also ideas anyone might have beyond what we've been able to think through. So to talk a little bit about the process that currently exists and where the account management people, they really want it to be automated. Our account management, among other things, is the lead of a consortium, and they have sort of a master contract with a very large public agency in Germany. And they're responsible for staffing a wide range of technical projects. These projects are often complex. They have multiple sub-projects. They have multiple roles within them. And this is something, the parsing of what goes into these roles and the requirements, that's something that's done manually right now. This is also going to be automated in a separate undertaking, but this is all related. Just to give a sense of how much work is involved with this, they can get up to 8 to 10 requests a day for this sort of feedback with possible candidates. And the process currently runs, it's also manual in the sense that our team leads are said, we need to provide candidates, they're prompted, who should be in the running for this. When that feedback comes back, the manual evaluation of the candidate profiles begins. And this is a scoring process, which I'll show a bit more of in a second. And then a checking of available skills, tools, methods, project experience to assess if the candidate is a really good fit. And what they produce at the end of this process is a ranking of possible candidates. And then they also check the profiles to make sure the profiles are appropriate to be put forward. Very, very time consuming. There is an entire consultant position that's typically involved with this. And the hope is, of course, to save money, but what they really are hoping for is not to eliminate the position, but to free the person up to do what consultants do, which is to work with clients and to book billable hours. To move to our data sources, the first thing I wanted to show is in sort of example of what the project or tender requirements look like typically when they come in. The original is in German. I can't actually show the exact original for privacy reasons, but in this case, the requirements are not that unusual for the kind of position they're looking for. And you can see that it's fairly repetitive at the beginning of each line, but then specifying, say, experience with Apache, experience with SOAP and REST APIs, SQL, and these sorts of things. This particular data is very easy to read in. What is more of a challenge, and this comes up again and again in our in what I'll be talking about in our work, is that there's a lot of terminology, there's a lot of domain-specific language here. And we've constantly been looking for ways to deal with this in the matching process. And just to give a sense of how much this is, there are maybe 10 to 12 core lists that are here, but these are the things that constantly vary. And so it's difficult to come up with, say, just a set database. This is something that comes in sort of live. The second big chunk of data that we're looking to work with are the employee profiles. They exist in PDF and in Word formats, and they're arranged for the particular roles in the agency. This is on the right is really just sort of a mock-up of what that looks like. I also can't show actual profiles, but this is just to give a sense of the structure that's there. And what we have typically focused on then is reading in these various sections and representing the various components, education, certification, skill matrix, and there can be anywhere from 3 to 10 projects that might be relevant. One of the things that is really just a programming issue is the order of these elements can all vary between profiles. We've managed to take care of that pretty well, but we're dealing with, even though it's fairly stable, over 70 profiles in the current pool. And 70 may sound like a lot. It's actually, for machine learning, not as much as we would like, but I'll say more about that in a bit. Then the last piece of data that we have are sort of test data so that we can see what people have done manually in the past. And this is useful for us, one, because this is the format that we have to sort of target in sort of presenting our results, but to also say this is sort of how we assess how well we're doing with the algorithm that we're developing. With what you see here, you can actually see this should look familiar. You see the project requirements listed on the left, and then columns for candidates and the score that the consultant has determined after inspecting the profile. And you can see it runs from 0 to 3 in terms of no experience to the highest level, expert level. Each one of these is scored, and then there's a sum at the end. And the goal is then to rank from most points to lowest points, and also have a sense of where this ranking is coming from. And in this case, it's the M1033 with 27 points would be the top candidate, and then EX1045 would be the second, and so on. So one of the things that is important is it's a relative ranking. So it's not that there's an expectation that any algorithm we produce is going to be producing the exact number of points per se, but to get a sense of who is the best candidate, who's second, who's third. And this is quite nice with our stakeholder. They actually usually have a couple of people ranking the candidates, and they don't necessarily, as humans, agree. So that there's an understanding that our algorithm, may not be perfect, but the key thing is to try to get the relative ranking important. and then to also understand in our algorithm how we have scored on the various requirements. So this is just background information to sort of give a sense of sort of how we're looking to present things with our algorithm. I would like to then move into the realm of the approaches that we're taking. And before I get into the specific approaches themselves, just this little word about how we work in the analytics team. We have an empirical approach. We're an agile team. We work with Scrum. We take that quite seriously. So we're iterative, and we try to ground our results as much as possible, metrics and these sorts of things. We work with baselines. So we're looking to implement familiar methods to start, try to be simple, and assess from there if we've achieved something that can be worked with, or whether we have to continue with additional methods. And usually that means more expensive solutions. Our documentation, clean code, and version control are something we also think are absolutely essential. And we, at this point, are working primarily in Python. We can work in R as well, but we also want to work open source. The first approach that was taken, this was before I actually came on the project, was, we can regard it as a baseline. It was the approach that was familiar to my predecessor, who did quite a lot of work in semantic search, and looking at the kind of data that was there, unstructured, unlabeled, to a large extent. He decided to try out named entity recognition as a way of developing something of a normalized term base and related terms, so that he could sort of narrow down all the variability that was there. And he developed a system for scoring the profiles versus the tenders, using term frequency, inverted document frequency, and word2vec embeddings. I'm not going to say too much more about it, because in the end, the results that he was able to achieve weren't producing very much differentiation. And it was exactly at this point where he left the MID, and we took over the project from him and decided, rather than try to refine this, we would take another approach, which was to go directly to LLMs, and specifically to transformer-based semantic similarity. So for our second approach, just to say a little bit about what goes into it, we're doing, I think, a fairly standard approach to it, but if you're not as familiar with it, semantic similarity is an algorithmic comparison of text units to determine how similar they are. And with the transformer models, it's possible to extract embeddings for the words or sentences or whatever unit you're dealing with in language, in order to have vectorized representations of the requirements, and this, in our case, in the profile elements. What you see on the right is something of a very simple depiction of what this process looks like. And you see in something sort of language space, this would be, in our case, the German language. Over with these models, it's actually something like 768 dimensions. I'm showing just two, but the sentence experience with SOAP and REST APIs would have one vector in that space. Experience with API interfaces would have another vector. And something like experience with Java would have its own vector. And you can see that in this representation, but also if everything's working the way it's supposed to, the vectors for experience with SOAP and REST are much closer to experience with API. And not just because the word API is in both, but because they have similar meanings. And it's possible then, doing the cosine similarity of the angle between the vectors alpha, to determine how similar these things are in a numeric sense. And this is sort of how we've approached things. We've wanted to go fairly standard at this point. This is a technique that's well described. And one reason I'm not showing code about this is that our code is fairly straight up what you find when you research these techniques. What's a little bit new for us was then we had many different sub or vectors within any particular requirement. We decided to develop a weighted average of the similarities in the various sections and arrive then for each requirement with a score for the profile. And because we wanted to score from 0 to 3 based on the relative similarity, we then developed thresholds based on the weighted average of the cosine similarities. And this is what's represented there in the small table to the right. And this is something of an empirical question, where to set these thresholds. This is something that quite a lot of trial and error has sort of gone into this. To actually say a bit more about the things that went into our initial approach, we did a great deal of experimentation before we got things to sort of stabilize. As I mentioned before, we're working in Python. We're constrained that we have to work in German. But we still managed to find a number of fine-tuned models, BERT, Roberta in particular, and the appropriate tokenizers that go with them. One of the nice things about working with transformers is the amount of natural language processing that actually has to be done to text is lower than in many other cases. You don't have to lematize, you don't have to stem generally. Tokenizing is just breaking up the text into chunks that are usually word length or just a little bit smaller. There are various approaches to that. And we can talk more about these different models, but these are the main ones that we experimented with. We had a number of terms that were 1 word or 2 words long, but then also a number of sentences. So for us, one of the things we had to clarify was, are we going to embed at the word level? Are we going to embed at the sentence level? Or how do we want to approach that? It turns out that the profile texts at first were challenging, how we would want to ingest them and what we would want to do to the text. The previous approach had tried to extract keywords, reduce down these requirements to their most essential parts, the most important ones. Whether we wanted to go that route here, whether we wanted to leave the text completely untouched, or whether we would slightly adjust the text. And then finally, given that we have a lot of domain-specific terms, whether we would in fact benefit from a fine-tuning of the model. This is something that's possible with these models. And so these are all things that went into our initial set of considerations and experiments. And I'm not going to show this step by step because it was quite messy. But in the end, we ended up getting a stable baseline that also showed improvement, and to give a sense of sort of what went into that. We ended up going with the Hugging Face library, which is quite convenient in a number of ways. It gives a very decent pipeline. It also enables you to test models against each other. And we decided to go at the sentence level, just based on the results that we were getting. And the model that we ended up going with was the Paraphrase XML R multilingual V1, which is a pretty powerful model. It's actually also trained in not just German, which is maybe another consideration depending on what you need to work on. We ended up then also, just as a point of information, converting our PDF files to Word, and then used the Python library docx to convert the tabular data to data frames. And that ended up being a lot smoother than we expected. And I can say more about sort of what went into that if that's of interest. And we ended up also finding that the best results came from the least intervention for the most part in the texts themselves. So simply reading in the texts and getting their embeddings was the thing that produced the best results all along the line. And for this particular round, we did no fine tuning, and we saw something of an improvement in the metric that we developed. It's something that we did as a custom metric, and what we developed two of them. One was to score the different requirements and compare in the test files to what humans had done, and sort of have an sort of absolute difference with respect to the human scorings, and then also to look at the relative rankings and see how many differences our algorithm has produced. So it's still, we weren't very happy with this result, or didn't think we were ready to go to the stakeholder with this, but saw a market improvement and thought, okay, LLMs are the way to go. And then went into trying to figure out, okay, what can we do with respect to the algorithm, to our process, to make things better. We then, because we had so much domain specific language, decided we would try to fine tune the model. This is, I think, also something fairly intuitive for people who have worked with transformer models and with this sort of situation. And we had seen in other projects that fine tuning actually can be really worth the time and effort. Because we don't have that much data, we were limited to 150 manually labeled sentence pairs. We labeled them things that were very similar, things that were very dissimilar, to try to give the model a sense of what kinds of things we were going to be testing for. And we saw that things got a slight bit better, but we were fairly surprised that fine-tuning in our case didn't produce the results that we were hoping for. And probably it's because we don't have enough training data available. And not really, after talking to our stakeholders, we weren't able to find more training data. And given that it was also extremely time intensive to run this training, we decided that we would have to do something other than the sort of standard fine tuning of the model. And this is where we get into terrain that I think we can debate whether it's the best way to go or not, but just to sort of give you a sense. We named this a kind of manual fine tuning, and we spent some time inspecting sort of where these similarity scores were coming from, tried to figure out, does this make sense or not? And if something doesn't make sense, sort of what went into that. And we went ahead and at first we simply read in text and looked at entire files. The stakeholders said they actually had a fairly fine-tuned process that was involved. And we went ahead and weighted things like project duration, went to look at the treatment of project tasks. One by one, they were actually read in as an entire list of things. You could have as many as 20, and try to see if breaking them up produced more accurate results. And one of the things that we noticed, if you noticed it when I showed the project requirements, every single sentence practically begins with project seeks. And we found that when we removed project from those sentences, we were getting much better results, because project in this context seems to be something of a loaded word, because everything is involving projects. So we pulled those things together and in fact saw some improvement, particularly in the scoring, but in terms of the ranking, we were still not getting quite to the point where we thought that the algorithm would really produce something that would be useful. And we went ahead and left the profile texts and their entities pretty much as they were. We did remove project from the requirements, and we went ahead and, after we noticed a number of patterns, had more feedback from our stakeholders. And one of the things that the model or the embeddings tended to lump together were things like coaching and trainer and workshop training session and these sorts of things. And this is something that our stakeholders actually strongly differentiate. On the other hand, things that for the human scorers, dashboard and report are fairly intimately linked. They weren't being put together, and the model didn't know what to do at all with technical names such as ServiceNow or SQL or Java. That was also something of an issue. And we sort of looked to adjust the similarities to reflect these priorities that went into the scoring process. And what we saw, and you can see it on the right, is the metrics. We have dropped the deviation in the scorings down to 6, and our candidate rankings are much, much closer to what a human had produced and what we expect a human being would produce. And so at this point, we decided that this was the approach that represented the direction we would go. And one of the things that I'm not that happy about, but I think we don't have a choice at this point, is developing this kind of approach has meant maintaining a list of the things that we have to sort of manually adjust for. And this is not ideal from my perspective, because it's something that you have to invest time in. It can produce errors if something goes wrong in sort of the more technical side of things. And it's not something that I've seen described in literature in this sense. So this is something of a solution we've taken to solve our problem, but happy to hear if there are other ideas that people would have. And so what I wanted to do in the last few minutes that I have, and just sort of showing what we've been working on, is one of the things that's interesting to us is when we went ahead and got to this point where we felt, okay, we could show results to the stakeholder, it became apparent that some of the stakeholder scorings, the human scorings, were, when we inspected things closely, not completely comprehensible to us. And the algorithm turns out to be more correct. And so to give you an example, what this presentation is showing is a color coding of where our scorings match the human scorings. And so where it's green, that's where our scoring matched the human scoring exactly. Off by 1 plus 1 minus 1 is yellow. Red is something more alarming. We're off by 2 or more points. And but you see these gray flags. And these flags were things that we marked because from what we could see in our inspection, the algorithm was actually right. And we couldn't completely comprehend why the human scorer had come up with the scores that they had. And this has happened often enough that we're having to get feedback and say, is it the algorithm that's wrong, or is the algorithm actually doing what the stakeholder wants, and should we proceed in this fashion? And well, this is sort of the test verification process that we're running through, but it's not quite as automated as we would want. But what we can see here, this is what this metric is scoring. And you can see in the left corner, relative rank for this particular project is really pretty close to what the human beings would have come up with the exception of this M107. This candidate got scored very high in an area where we're not quite sure how to reconcile that. But if that candidate hadn't been scored in this particular range, our ranking would have actually been dead on with the human one. So just to also give a sense, this is something of the way our output would also look when we deliver it to our stakeholders. And there's going to be another round of testing that has to go into this. But of course, we can't color code things on unseen data because there's no human reference actually to work with at that point. But the next step, and sort of this is an ongoing project. We've been working on it for a few months now, and we're confident now that we can produce useful results. We're going to be running on unseen data in the very near future. And part of what our process will look like is we'll be looking to collect human feedback on our work, first to train the algorithm, but of course, we need to be very careful that human beings verify the sorts of things that we're producing. Important because of EU guidelines that support human supervision in the case of AI. But we also anticipate if this project runs long enough that we could also maybe implement an additional machine learning process to learn from these sorts of things. Long term, we're looking to implement a pipeline and dashboard so that this is actually something that can largely be triggered by account management. We really don't have to be in the loop all the time. And long term, this is also something that's going to be implemented and incorporated in a large automation process from beginning to end, but one that's quite crucial. It's one that ultimately is going to, I think, speed things up quite a lot and save a lot of time and money. With that, I'm going to wrap up my comments. I'm happy to answer any questions that are there or address any feedback.
So much, Peter, for this webinar. I think it's been really clear and really insightful. I do invite anyone that might have a question in the chat. I think we'll just give it a few minutes in case people are shy or just thinking about their questions, finding the right words to express it or anything like that. But please feel free to reach in the chat. But yeah, I think it's a really, really interesting HR data science use case that's showcased here today. And definitely food for thought in terms of well, what are concrete examples that companies are running today, but also B, the thought process and the tools and efforts that come into these types of projects, and definitely something to show for it. But all right, maybe we can just give it a few minutes. I do think it was very clear, so that might also explain the lack of questions. But yeah, maybe we can wait just a couple more seconds in case people are hesitant to find. Usually the first question sparks a few others. So that might just be the case for us today. Maybe in the meantime, I can already ask maybe one quick question that I thought about when hearing about the talk. Is everything compliance and regulatory regarding some of these projects? Where does that come in? What's the thought process? Who's involved? Especially given that we're seeing, new rules and regulations come up regularly. I'm thinking about the AI Act. I think about also how HR data was mentioned in these types of regulation. Where is that taken into consideration? What are your thoughts there? And yeah, what is currently your views on those topics?
I think this was the first thing that we were told before we actually even heard what the desire was, which Germany is very, very serious in terms of data privacy. Most consulting companies are very, very strict about confidentiality. I mean, you probably noticed I didn't name the agency. I have not shown the original of anything that came from them. And we actually internally had to get clearance to even be able to see these things because we're not actually in account management. We had to sign non-disclosure things even though we're in the company, and then to look at fellow employees' profiles, that was a really careful process where we were familiar with the data protection policies of the company, but we had to go through that one more time, sign various forms, and document that all of this was being handled appropriately. And one of the main implications is then sort of where our data is held. We need to actually not have it be local on our laptops to the greatest extent possible. It needs to be kept on our server. I mean, it's sort of, our servers are in a virtual private cloud, and then it's sort of one of those long debates about whether is it sufficient that that the company says, oh, this will only be stored in Europe, or is the cloud data going to be stored anywhere? That's sort of out of our hands. One of the things that I didn't mention this as a constraint because it goes into a completely different range of issues, but a whole nother kind of approach would be to go generative AI with this sort of problem. And at this point, we haven't been able to do that because we're really not confident that we could go, say, to ChatGPT or to any sort of other online instance and simply throw this data around. So this is something that we probably will also revisit. We are in the process of setting up our own private open source generative model, and to have something of a chat instance locally that is protected. And this is sort of something that I think a lot of people understand. Oh, we have to be very careful with the data, but the desire in all of the hype with respect to ChatGPT was like, oh, just throw it up there and we'll find this low-hanging fruit and everything will just come back magically and we don't have to invest any time. That hasn't panned out for us at all at this point yet. This is, I think, probably, data concern is really at the core of this. And we also took steps to anonymize. You notice that there were no candidate names. It was all just sort of, M for internal or X for external candidates. So, we even try not to know whose profiles we're actually looking at if we can help it. They're our colleagues, and we don't really need to know on that level sort of what they're about. But it's something that we're taking, very carefully.
Yeah, definitely. I think this was one of the follow-up questions, which is, kind of building up LLMs on your own versus the Gen AI, maybe API calls that could have also somehow maybe done the trick. I think there's a lot of also kind of blurriness about what are the capabilities, what are the use cases, and I think data privacy for sure is a very interesting and relevant topic. I haven't seen any other questions pop up in the meantime, so I'll just maybe wait around for a few seconds, but I do think that in the meantime, I really want to thank you, Peter, for accepting our invitation.
Sure.
It's really been a pleasure to be introduced to one of these specific use cases, understand what's going on behind the hood of some of our interesting topics, and also gave a quite thorough the application process for building as kind of a local LLM and using NLP technologies to solve some kind of traditional business use cases. So thank you very much, Peter. It's been a pleasure.
Sure.
And looking forward to hearing more about this project in maybe a few months' time.
We'll cross our fingers that it gets better.
All right. Thank you, Peter. Thank you, everyone, for attending this call. In any case, there'll be a recap email with all the information. And once again, if you're ever interested in a data science, data analytics, data engineering, or DevOps course, feel free to check out our website. We have some great courses, great content, and also great people to speak to in case you're interested about one of these programs. Thank you, everyone. Have a great day, a great weekend, and we look forward to seeing you very soon on Data Scientists' webinar series. Goodbye.
Bye.